So, good afternoon, ladies and gentlemen. I'm going to cover data virtualization on steroids. But before I go deep in, let me a word of caution. I tend to speak very fast, and I'm not on steroids. That can be attributed to my Indian heritage. A quick introduction from a group perspective. I run the solution design and development group within Wells Fargo Wholesale Bank. And the group is a shared services organization. It owns infrastructure, software, and it covers a broad span of areas, not just data virtualization. Unlike some of the conversations which we heard this morning, just specifically around data. I mean, we have shared services around grid computing. We have shared services around delivery channels facing internet, so on and so forth. The group's charter is beyond wholesale. It's across, we have some 70 lines of business within wholesale. In the new Wachovia Wells merged bank. So that's the overview in general. This presentation is not about data virtualization overview. You guys have heard enough about it. Neither is this presentation about MapReduce, and I tend to use word MR pretty liberally, but this is neither an introduction of MapReduce. I'm assuming that our friends in media fixated on Google has already talked enough about how they do search indexing using MapReduce, and you guys are already excited about it. This presentation is specifically about how we were a conventional data virtualization customer, much of to the same experience and the context that you guys have been hearing this morning and yesterday, and how did we merge the MapReduce concepts, and what are the business and technology implications of it, and what does it mean really to the ETL space, what does it mean to the analytics in particularly. That's one of the hot areas within the merged bank. If time permitting, we'll go into the detailed use case of this. So quickly, from a data virtualization perspective, typical footprint, we started in 2006. We have a wide range of use cases from client master reference data to CRM data to operational data to risk data, going against Sybase, Oracle, going against Sybase web services, exposing views in ODBC, JDBC, or exposing it in the form of web services. The conventional play for composite or data virtualization within Wells Fargo actually came from Wachovia Corporate Investment Banking, and we had that footprint since 2006, as I said. We had predominantly played with two flavors of data virtualization. A tool to, I would say, modernize your applications, in the form of data services being exposed, having data services layer exposed in the form of web services as a legitimate first-class citizen, as well as quickly exposing data in your conventional way of exposing using an ODBC, JDBC source. That's where we started from. It used to be a Wachovia CIBT thing deployed predominantly in the East, but now we are trying to socialize virtualization in the larger Wells West, and trying to orient people who are predominantly ETL oriented, and then putting it into their roadmap that before you consider an ETL project, have you considered or given a thought to the virtualization dimension of your ETL initiative. So that's where we are within the Wells Fargo perspective. Why this whole integration of data virtualization and MapReduce matters? I mean, we have heard enough from several folks, right? Composite or virtualization as a philosophy is great at breadth, but when it comes to a breadth of data sources, but when it comes to, and I'm stealing your terminology, breadth, but it's not great at the depth, or it rather delegates the depth to some other high performance technology. So if you say, hey, I'm not willing to wait for 4 hours because the stored procedure is taking 4 hours, then now it becomes automatically in a batch oriented, ETL oriented problem set. So that's where the ETL is great, but virtualization, why not having to wait for a long time? So that's That was a specialty. So if you look on the left-hand side, as the data volumes are going on, getting bigger and bigger, the conventional tipping point is where you see. And what we have done is we have taken MapReduce and kind of looking to move the tipping point towards more real time and towards larger data sets. So that's the opportunity that we are trying to explore and make it a second nature across the wholesale and then eventually in the wider enterprise. The idea fundamentally DVMR is like data virtualization, which is DV, and MapReduce, which is MR. When you combine together, the output is bigger than the sum of parts. So that's the whole terminology. The MR aspect of DVMR presentation that we are going to talk about today is fundamentally based on QGrid. So QGrid is our internal grid that we built such that people can use that grid on a shared infrastructure. We can do MapReduce on top of QGrid. However, the notion of MR could be your Hadoop, or you could build something like QGrid using GridGain or anything else that you could think of. Or you could use simply Data Synapse Grid Server if you want to. But QGrid is our internal internal framework on a shared services infrastructure. Briefly, QGrid, Q stands for query. The whole idea was how do I create a specialized MPP kind of multi-core layer, which is neither on app server layer nor on the database layer, and offer it to people so that they could do some really high-end processing. When we were designing QGrid about a year ago, I'll be honest, I didn't know what MapReduce was. The whole philosophy was we were from the grid side of the investment banking side of the world, and we were very used to grid. So we were trying to develop a computational grid which co-located with a data grid. So we didn't have that solution, right? So if at all, we were trying to create what I think there is another company in the market called Gigaspaces. They probably have something similar where they have computational grid co-located with your memory grid. And the whole objective was we wanted it to be elastic. And we were, again, if you just have a grid but you don't have data, then what do? Your grid is fast, your bottleneck is pushed down further onto data. So that's the problem we were trying to solve. And then somebody came and said, hey, looking at it, you could do MapReduce on it. And I said, what is MapReduce? I don't know about it. Then we started looking at Hadoop. We evaluated Hadoop, and Hadoop is great. But fundamentally in Hadoop, we have to move the data, ETL it into a Hadoop file system, and that's the ETL step, and that's what we avoid in QGrid. So architecturally, it's not a very complicated idea as such. Towards the bottom, we have a elastic memory cloud service which we already had. Again, the concept is shared commodity hardware. On top of it, we had this memory cloud established. So for us, it was fairly simple to build a notion of a queue broker and a notion of queue nodes and notion of P nodes. And all the queue node and the P node are actually grid applications. And they are talking to each other in a custom protocol that we design. And on this side, we are talking about data intensive applications. So I hate to get into what is BI, what is reporting, what is analytics. So I kind of said I don't care. It could be a trading application. It could be a frequency application, HFT application trying to do backtesting. It could be a risk analytics application. It could be a fraud forensic application. Any application which needs either temporarily or for a reasonably long period of time a shared infrastructure, which typically they could get it on to a public cloud like Amazon, but simply because of your corporate security policy, you can't take your data over then process it. So then we have QGrid to do that. So that was the original intent. As you see, we have gone towards the model of no ETL, where we are saying is instead of bothering a data warehouse or a operational store with a complicated query spanning 10 million rows, what if I make a query lesser complicated and fire the query with smaller result set? So if I divide 10 million rows and fire roughly 1 million rows query, which might be efficient, then bother the operational store for that small query, and it should be able to take that, source that data into the memory cloud, and then process it using the P node. So that's the fundamental idea. And we could have any number of Q nodes based on how elastic you want to go, how big your data set is. Similarly, you could have different Q node types sourcing different data, and you could have different P node types doing different sorts of things. So that's the fundamental idea. Again, we are a shared services organization going through the usual political battles, my infrastructure, your infrastructure. The model is we support both the models. So we could have 4 quad core, Azules, 2 quad core, all our infrastructure. And you could have a QGrid over here, qgrid.wellsfargo.com treasury. So those guys are doing something over there interesting. They say that, hey, I need more power and I don't have that much machines to support their QGrid. So basically they could add incrementally only what they need, and we can guarantee that their boxes will be used for only their processing. Nobody else can go there, and that's the provisioning part of the QGrid. The value proposition at a business level, as I said, multiple use cases, right? I mean, most of the time you hear about MapReduce and you're talking about 20 terabytes of data, log file processing. Yeah, we have a set of use cases around that, but we are talking about frequency trading application, backtesting. We are talking about risk engines, risk analytics. Fraud forensic is another example, or just trying to accelerate mid to back office, right? Somebody is trying. I mean, I got an email just now, just morning. Our FX team is trying to solve a problem where at the end of the day, they are valuing FX options portfolio some 300 times, and now they need an environment just for that end of the day processing to make it fast. So should they go and make a case for 10 server based solution, or should they ask for those 10 node solutions for a little time? So that's the model that we are taking them to. Technical perspective is many people get the idea of grid, get the idea of MR thanks to the media, but then it's not that easy. I'm not trying to shy away from being modest, but I'm saying it's like fundamentally people have got used to the idea that, oh, we do multi-threaded programming, but then the app server world came and said, why do you care about multi-threading? Just write the EJBs and specify the number of instances and you're done. Now getting those folks who unlearned multi-threaded programming and now say, hey, now do multi-core programming. If I have 4 nodes, each node having 2 sockets, each socket having 4 cores in it, how do I write code? If I'm a plain vanilla .NET commodity J2E shop, how do I write code which can take advantage of that hardware? So that was missing. So QGrid has that value proposition that wherein people can come with those commodity skill set, be it Java, be it .NET, or be it C++, and simply implement certain interfaces, and they are on a queue. They have their own QGrid and on a shared infrastructure at a time and the size they want. Why we decided to integrate Composite? Honest answer, QGrid didn't have a SQL interface. That was the biggest problem I saw. I didn't have money to go and buy something like an Aster data, which we eventually are now experimenting with. The greatest value of an MPP based databases, and I was seeing TED slides, is a lot of databases are becoming MapReduce enabled. So now you could say, hey, my model of the data is SQL, it's partitioned across the commodity hardware, and now I can do a select star and then have a table function, and a table function is operating on 10 million rows, sharded onto maybe 10, 20 nodes using some kind of a sharding logic. So I didn't have that. QGrid was an in-house framework. People didn't have enough big of a problems to go and adopt MapReduce or make a case for Hadoop. And we had QGrid, but then some of the folks wouldn't use it because, hey, it doesn't have a SQL interface. I said, hey, you have a web service interface, and we have a kind of a streaming interface. So we said, okay, if I extend, so the fundamentally what we did was, we said, okay, data virtualization is great. I can quickly convert things into a view, ODBC, or I can take the same view, publish it as a web service. I'll kill the web services gateway programming, At the same time, I can have the same view published as an ODBC. I'm kind of addressing a wide variety of community if I just address that. So to make QGrid SQL compliant, we said, hey, let's connect it. And the way we connected it we took the APIs of a composite and implemented a custom data source. And that custom data source is simply going against the QGrid. So our composite infrastructure, when somebody asks the question, right, what do you do when you have a very complicated transformation? Do we do it on composite? The answer is no, we don't do it. Right? So what we do is, when we encounter situations where we have humongous data and very complicated processing, where you have to go beyond, your SQL capabilities and you need a programmatic description. So we said, hey, let's not bother the composite layer and the infrastructure. Let's create a layer which is neither a database. Currently, what do? You write a smart stored procedure, right? Or you write a smart stored procedure and scale your infrastructure. And depending upon if you're a rack shop, your scale out ratios are going to be a $250,000 machine, M5000, depending upon what infrastructure you have. So that's the model you were in. So what we said is, let's create a layer which is neither app server, nor composite infrastructure, nor database layer, but it's a commodity layer. And a group like ours, which has infrastructure, has people to support infrastructure, can support that things for ETL kind of activities, for some questions which you need to ask, but you cannot ask them through composite because of the data size or because of the complexity of it, and process that much amount of data in much faster time. So now the validity of composite in terms of being wide is still there, but the depth which was missing is brought to you by this particular MR infrastructure layer. So now a 20-minute fetch, not even processing, is now 19 seconds fetch and process data. So you're giving the ultimate end result, which you care to mix it with another data source to composite. So that's the whole idea over here. And we are applying it to the analytics. So analytics is the most hot area within the bank. Several dimensions, right? Two companies from a size perspective, Wachovia before merger was 120,000 people company. Wells Fargo was similarly sized. So now we are a 250,000 people company. And there are so many systems, so many data sources. It's just a lot of opportunity to cross-sell, a lot of opportunity to figure out where all fraud is happening. I mean, so those are two great areas which are very analytics focused. So we said, hey, what are you guys doing really? Now, people are trying to do data discovery and profiling. Now again, the word discovery has got nothing to do with composite discovery, and the word profiling has got nothing to do with Informatica profiling tool. These are simply the general steps. So what happens in step one? You find the data sources, identify issues with the data, and then you go into this negotiate with the data owner. No matter who says what, I will enforce the practices. At the end of the day, the person or the group who has data is the king, and they can create enough bottlenecks for you. So it's a negotiation process with data owner of cleaning it, reformatting it, bring the data into Excel, Microsoft Access, and then repeat the process for end data source. And that's how our analyst life cycle started with. And if you really look at it, step one is of lowest value, but it's the most difficult step. Then you go to the step two, where they have figured out, oh, the data looks good. I figured out, oh, zip codes are not in correct format. And in Excel, now I'm going to do some kind of a modeling. But again, Excel, 65,000 row size limit. I think the new version is probably more than 1 million or something. But they're trying to do it on their local desktop. So we said, okay, how can we help you do what you do in Excel inefficiently, where you actually chunk your 1 million records in 65,000 and run some formulas and then create an extract out of it. How do we help you over there, right? And then finally, they are going to publish the model. So we said, okay, your level of difficulty, as I said, highest in step one, somewhat highest in step two, and then step three is pretty well known at this point of time. So we are proposing and socializing that with data virtualization, we can help you in step one and two using composite, normal composite, not with the discovery. We can accelerate the discovery process by really quickly building the data views. and then publishing them for you to access in Excel, SAS base, or what have you. And all the filtering aspect, all the data merging aspect, again, we can bring in the DVMR part. I mean, data view creation has a nice GUI, and it's a 2 to 3 days of effort. But for people in my group who know QGrid and the infrastructure in and out, if we are explained what the data is, what they want, it's a 3 to 4 day effort for us to give the analysts what they want as a SQL available function. So now we are connecting data virtualization and MR and giving them DVMR to even solve the step 2. Step 3, I publish it through give runtime issues. So if your model is repeatable, we have QGrid to run over there too. So from a business implications, right? I mean, why are we even trying to do this? So we said, hey, what are the key raw materials for dollar-worthy analytics? So we said, okay, we really need smart quants. At the end of the day, you can't write a smart model unless you have a smart quants. Then you need good data from diverse sources. That's another second important thing. Then you need good sample size. Sometimes you may have a model which looks very promising, but then the moment you run that model over 5 years of the data, the model starts to fall apart. And our housing market is a good example. Cost-effective technology and infrastructure. At the end of the day, you may have a question and whose answer is unknown to you. What is the impact of that answer? You may have a $25,000 value of that answer in the form of a revenue generation or in the form of a cost savings. Or you may have a $5 million cost save or revenue opportunity. You just don't know what the answer is. So we said, okay, fine. How does DV and DVMR help? Well, we'll make the life of LOB quants easier. Allow them to focus on, just look at the data. Just be expert at your data engineering skill set. Hire the quants, hire the guys who understand k-mean analysis, hire the guys who can do cluster analysis and all sorts of stuff. We will worry about the IT part, right? We said, okay, how do you give good diverse data sources? Faster time to market, right? We can accelerate the discovery process. And then we can, accelerate even the, by giving a virtualization option. We're trying to say, hey, ETL is amount is probably cut down. So we are getting good data from diverse sources faster. And then we are saying, hey, at the end of the day now you're talking about sample size. We are providing them a technology to harvest terabytes or petabytes of data. Or sometimes the data is not in terabytes or petabytes. The data is simply taking longer to process. So we are giving them ability to process that data much faster. So they are able to deal with data with time series which is not in minutes, but it's in probably microseconds. And finally, we are talking about a cost-effective model. We are all about shared services. So the data virtualization service that we have established within the group is also a shared service. And the development is done by somebody else, and that's something I'm still trying to reconcile whether it's good or bad. But the whole idea is that the virtualization aspect as well as the MR aspects are available to you as a shared cloud infrastructure, private cloud infrastructure, right? So we are incrementing in increments of $1,000, $10,000 to $20,000 in terms of infrastructure cost. And B, the people who are using it may not necessarily have to own this. So that's the value prop for the DVMR part of it. How am I doing on time? Am I speaking too fast? Are you guys asleep already? Yeah. So here is a use case, right? I mean, just as an example, this is a use case where I keep on telling people that, I mean, MR or MapReduce is not just about big data. Sometimes it could be about making big time small time, right? So here is an example. Here we have an enterprise audit database which is sitting at a portal, at the front of the portal, an internet-facing portal, and it's getting trades. It gets records from multiple systems, some which are trading, some which are not trading, and it has several columns. But the column of most interest is that app props column. That column is, I think, a glob or an image inside this database, and I saw it was defined it to be a 2 gig. And this data is stored as, so the data is structured itself, but it's stored in a column which is a binary clock kind of a column, and the size of it is unknown to me. It's been specified to be a 2 gig thing. And now what we are trying to do is, well, there are trades which are coming in from a particular system, and we are trying to figure out how do I organize those trades per QSIP. How do I find some kind of a statistics around, buy, sells, what is the average movement of the stock, what is the average buy value, average sell value, that kind of stuff. So to do such a thing just in SQL, I don't think we will be able to do it without writing some complicated SQL and then involving some kind of a temp table. And we get into this, how do you do a group buy, right, on a CLOP kind of a thing, and how do you do like very easily. So this was a problem where we had 2.4 million rows. We just tried to read it. We said, hey, you can't do it in SQL. Let's move it onto the app server. Just to read that much data at one shot, 20 minutes. So what we did was we kind of applied QGrid to it. Now 20 minutes to source the data, and we haven't even processed it. Now we just put it onto QGrid. We say, okay, we will break it into smaller transactions, batch sizes, bring it. Each queue node will simply bring the data, start putting it into the memory cloud. The P nodes will start processing, and you finally get a streaming result on the back. So that part now, we have the results over here, right? It's not interesting initially, right? When the size of the rows are less, but as you go towards high end, right? Now we are trying to process it at an average time of 19 seconds. 19 seconds is a worthwhile time to wait, depending upon the nature of your problem in composite, to get the data which is processed. And now you can mix it with other sources, or simply not mix it, just have it as a view. So that's the power that we have now, which we didn't have earlier. The moment we went out for 2.4 million records on that particular source, we won't do it. Let ETL take care of it. Let ETL or something else process this and put it into a permanent view kind of thing. So I'm personally seeing a trend where MapReduce, I hate to use the word killing, but it's rhetorical, but MapReduce is gradually invading the ETL la-la land. And it's making it commodity in a couple of different ways. One of the ways which I see and hear is, why care about the data model when it takes too long to build a data model and you don't even know if that's the final data model? So why don't we just try to solve the problem quickly? Now to solve the problem quickly and without trying to boil the ocean and get the best possible answer in ETL may not be worthwhile. So now you make the ETL project really very important and then say, hey, thou shall make a good data model. Thou shall follow data cleaning. It becomes a very long process. So here we are saying is that for whatever worth it is, right, let's try to ask a point question. Let's try to just load the data in a highly denormalized way, try to process the data. Don't worry about the data model, get your answer. If you get an answer which is worthy enough, great. If you don't get the answer, you still haven't lost much money, which is what you couldn't do with your conventional ETL style. So I don't know, I haven't seen Informatica, but I was sitting in one of the data stage presentation. They are going gradually towards MapReduce kind of a metaphor. They don't use the term MapReduce, but they are going towards that. So to me, MapReduce has to become a first-class citizen for virtualization. That's where I'm going. As in business benefits are several, technology benefits are also several, I think, and I think it's a reconciliation time for most of people who have spent a lot of money on ETL to be challenged with, hey, I can virtualize the data. So they figured out, oh, you can virtualize the data, but you cannot go deep. But somebody else is saying, hey, I can solve the deep depth problem by doing MR. And by the way, you don't even care about the data model, right? Google was doing MR, now they do big table. They do big table, they don't do big database. It's one table, denormalized table. So those are the trends that we are trying to stay ahead of, and if not applied to all the use cases, but to certain use cases.